Okay, so on this particular problem, we're going to have a dice with 10 sides, and we want to throw it until we get an 8. So if I go D equals D, and this is, so I know, and this is the probability that D equals D if I make a table here. So if I think about this, on my first roll, if it's success on my first roll, then the probability of success is 1 out of 10. Now, when I go to my second roll, that means my first roll had to be a fail, which is 9 out of 10, and my second roll had to be a success. So it's going to be 9 out of 10 squared. For it to be 3, that means my first roll had to be a fail, my second roll also had to be a fail, and my third roll had to be a success. So now I'm doing 9 squared over 10 cubed. And the fourth will end up being, if I keep on doing it, it's 9, and so on and so forth. This is 9 cubed over 10 to the fourth. So if I keep on going, if I do 5, that's going to be 9 to the fourth over 10 to the fifth. So what keeps happening in this scenario, my probability distribution, the probability of D equaling D is simply going to be 1/10 times 9 over 10, where this is n minus 1, or sorry, D minus 1, for the D's that are up in this area here. So here's my D's and so on, because each time I'm adding one of these. This is actually what we call a geometric distribution, which you're not responsible for geometric distributions, but being able to derive this kind of scenario based upon the understanding, I think it's fairly fair game. So now, what is the most likely number of rolls? Well, that means which of all of these probabilities is largest? Well, that's going to be 1. So the most likely of this is going to be D is equal to 1. And so now, using technology to help me estimate D, what I'm going to do is I'm going to, I know that as I increase this, I could put more values in here, and then I would find the expected value, do one variable statistics, and see what I get. I know the formula is going to be 1 over 10, so you should get 10. When you start to multiply this out, do just a bunch of estimates, you should get 10. And then finally, if you want to find this particular one, well, that's the same as the probability of 1 minus the probability that D is less than or equal to 4. And so then you come around and you actually literally add these ones up and subtract it from 1. If you need more of an explanation, just let me know.